Have you ever wondered what would happen if you fell into a black hole? Black holes, those mysterious, elusive entities that reside in the vast expanse of outer space. They've been the subject of countless science fiction tales and have been the fuel for our wildest imaginations. They've been painted as cosmic monsters, ready to swallow us whole and cast as doorways to other dimensions. But what are they really? Our curiosity about black holes is as boundless as the universe itself. They're shrouded in mystery, an enigma of the cosmos that we're still trying to comprehend. Many of us harbor misconceptions about these celestial objects, often tinged with fear and uncertainty. But it's through our understanding that we can dispel these fears. So, prepare yourself for a journey like no other. A journey into the unknown as we delve into the heart of darkness itself. Stay tuned as we unravel the mysteries of black holes and outer space. Outer space, often referred to as the final frontier, is vast and filled with countless wonders. It's a realm that stretches on seemingly without end, a canvas painted with the brilliant hues of galaxies, stars, and planets. It's a place where the laws of physics as we know them can be bent, twisted, and even broken. To begin with, outer space is not just big, it's incomprehensibly enormous. Imagine, if you will, a beach. Each grain of sand represents a galaxy, and each galaxy contains billions of stars. Now imagine that this beach is just one of countless others, each with their own multitude of galaxies. That's a glimpse into the scale of outer space. But what makes outer space so fascinating isn't just its size, it's what fills this vast expanse. Galaxies, majestic worlds of stars, dust and gas, are scattered throughout space. Each one is a cosmic city, home to countless stars, planets, and possibly life forms. Stars, the shining beacons in the night sky, are nuclear furnaces, burning with a heat and pressure that's hard to comprehend. Planets, vast and varied, orbit these stars, each one a world of its own with its unique geography and weather patterns. Yet, despite all this activity, space is largely empty. It's a vacuum, devoid of air or atmosphere. This leads to conditions we don't experience on Earth, like zero gravity. Without the pull of a nearby massive object, there's no up or down in space, no sense of weight or weightlessness. It's a strange, disorienting sensation, but it's also a fundamental part of what makes space, space. So, outer space, the final frontier, is more than just a backdrop to the stars. It's a place of extreme conditions, a theater where the laws of physics put on a spectacular show. It's a realm of infinite possibilities, where every discovery opens up new questions, and every answer leads us closer to understanding our place in the universe. Outer space is a place of extreme conditions, unlike anything we experience on Earth. Now let's dive into the enigmatic world of black holes. Picture a massive star, many times the size of our sun, living out its fiery existence. As it burns through its fuel, the star remains stable, balancing the inward pull of gravity with the outward push of radiation from nuclear fusion. But all stars must meet their end, and for the most massive ones, this end is particularly dramatic. When these behemoth stars exhaust their nuclear fuel, they can no longer resist the relentless tug of gravity. The core of the star collapses under its own weight, and in a matter of seconds this collapse triggers a violent explosion known as a supernova. This cosmic event is not just a spectacle to behold, but it's also the birthplace of a black hole. But how does a supernova lead to a black hole? Well, let's take a closer look. After the supernova explosion, what's left of the star's core continues to collapse. Imagine all that matter, equivalent to several suns, compressing into an area so small, it's practically a point in space. This intense compression creates a gravitational field so strong that nothing, not even light, can escape it. This is the moment a black hole is born. Yet the birth of a black hole is merely the beginning of its story. These celestial entities are not just space oddities, they're powerful forces that can shape galaxies. Even though black holes are invisible, we can detect their presence through their gravitational influence on nearby objects and the high-energy particles they emit. Black holes are fascinating not just because of their existence, but because of the mysteries they harbor. Their interiors, hidden behind an event horizon, are regions of intense gravity, where our understanding of physics breaks down. They challenge our perceptions of space and time, and continue to be a subject of intense study and exploration. So, black holes are born from the remnants of massive stars, but what happens inside them remains a mystery. So what would happen if you fell into a black hole? This question has tantalized astronomers and armchair space enthusiasts for ages, and while we don't have any concrete answers yet, a few intriguing theories have emerged. Let's start with the most colorful one, the concept of spaghettification. Yes, you heard it right, it's a real term in physics, and it's exactly as it sounds. As you approach a black hole, the gravitational pull becomes so strong that you would be stretched out like a piece of spaghetti. This is due to what's called a tidal force, which refers to the difference in gravitational pull on the closest and farthest parts of an object. But don't worry, before you could even become a human noodle, you'd be torn apart at a molecular level by the immense gravitational forces. Of course, this is all theoretical, as nobody's ever been inside a black hole to test it out, and frankly, it's not a trip anyone would want to take. But let's take a step back and consider what a black hole really is. It's a region of space where gravity is so strong that nothing, not even light, can escape its grasp. This means that the laws of physics as we know them break down inside a black hole. One of the most fascinating theories about what happens inside a black hole is that time and space as we know them cease to exist. According to Einstein's theory of relativity, the fabric of space and time is warped by massive objects like black holes. This means that once you cross the event horizon, the point of no return, you would be in a realm where the normal rules of space and time don't apply. In fact, some scientists speculate that inside a black hole, space and time might actually switch roles. In this scenario, what we perceive as space becomes time, and what we perceive as time becomes space. This could mean that once you fall into a black hole, you wouldn't be able to move in any direction in space, but you could move in any direction in time. It's a mind-boggling concept, and it's only one of many theories about what happens inside a black hole. Other theories propose the existence of wormholes, bridges to other universes, or even the creation of new universes entirely. While these theories are all fascinating, it's important to remember that they are just that, theories. The inside of a black hole is one of the most mysterious places in the universe, and until we find a way to directly observe or measure what happens there, all we can do is speculate. While the inside of a black hole is still largely unknown, these theories provide some captivating possibilities. So, the next time you look up at the night sky and ponder the mysteries of the cosmos, remember that there's a whole universe of possibilities waiting to be discovered. We've journeyed through outer space and dived into black holes today. It's been a whirlwind tour of the cosmos, so let's take a moment to reflect on what we've learned. We started our journey by exploring the vast expanse of outer space, that infinite panorama of stars, galaxies, planets, and other celestial bodies. It's a place where the laws of physics as we understand them on Earth are tested, twisted, and often turned upside down. We've seen how this final frontier continues to inspire our curiosity and drive our scientific endeavors. Then, we delved into the birth of a phenomenon that has fascinated and puzzled scientists for decades: black holes. Born from the remnants of dying stars, these entities are so dense and possess such extreme gravitational pull that nothing, not even light, can escape their grasp. We've seen how their formation is a powerful testament to the forces at work in our universe. Next, we ventured inside the black hole, a place where our understanding of reality starts to unravel. We discussed the intriguing theories about what happens within these cosmic beasts. Do they lead to other universes? Or perhaps they're gateways to different dimensions or times? While these are just theories, they highlight the exciting possibilities that black holes present for our understanding of the universe. Lastly, we've recognized that our knowledge of outer space and black holes is continually evolving. Every new discovery, every refined theory, brings us one step closer to making sense of these cosmic phenomena. So as we conclude our journey, let's remember that the universe is filled with mysteries waiting to be unraveled. And let's continue to gaze at the stars with wonder, curiosity, and an insatiable thirst for knowledge. While there's still so much to learn about the universe, every discovery brings us one step closer to understanding the mysteries of outer space and black holes.